Physics 150 Electricity and Magnetism Experiment 1 Coulomb's Law Objectives The first objective is to satisfy Coulomb's law experimentally. The second is to study the parameters that affect the electric force. The third objective is to find experimentally the electric constant of K. Theoretical background Coulomb's law, the magnitude of the electric force that a particle exerts on another is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Mathematically, the magnitude of this electrostatic force Fe acting on two charged particles, which is Q1 and Q2, is expressed as Fe equal to K, where r is the separation distance between the charged objects and K is the constant of proportionality called the Coulomb's constant, which is K equal to 9 multiple 10 power of 9 Newton meter cube.
Procedure Part 1. First, the following link was clicked and the charge Q1 and Q2 was fixed. Their values were written in the table 1. Second, the distance between the two charges was changed as shown in the table 1. Third, the force value for each distance was recorded. Fourth, values for r squared and 1 over r squared were found and filled in the table 1. Procedure Part 2. First, the following link was clicked and the charge Q1 and the distance r was fixed. Their values were written in the table 1. Second, Q1 was controlled and fixed at 5 microcoulomb and the distance between the two objects was fixed at 6 cm. The result was recorded in table 2. Third, charge of object 2 was changed as shown in the table 2 and the electric force between the two objects for each Q2 was recorded in table 2. Data. This is the result recorded in table 1. This is the result recorded in table 2.
This is our graph for this experiment. Graph is about Fe versus R. Second is Fe versus 1 over r square. The graph about Fe versus Q2. Next is data analysis. Data analysis for part 1. From the graph Fe versus R, the comment from this graph is based on the graph. Electric force Fe is inversely with distance r. The graph shown that the distance r is gradually decreasing and electric force is increasing. So based on the data, we got a curve-shaped graph. The graph increasing from the r equal to 0.08 meter. And second question is related to graph Fe versus 1 over r square. We can find the electric constant K. So K measured is equal to 8.99 multiplied by 10 the power of 9. And third question is the calculation, the percentage error in K. So the percentage error in K is equal to minus 0.11%. And then this is for part 2. First and foremost, from the graph FE versus Q1, based on the graph, electric force FE is directly proportional with the charges Q2. The graph is shown a linear graph and the variables is gradually increasing. So based on the data, we got straight line graph. The graph increasing from the starting point and it move upward. Okay, and then second question is how we can find the electric constant K from this graph. The calculation as follows. So the K measured is equal to 9 multiplied by 10 to the power of 9, and the percentage error in K is equal to 0%.
Okay everyone, hello, my name is Fatin Nor Maisara and I will be talking about the discussion and conclusion. Here we have the discussion. Based on the experiment carried out in part 1, we had fixed the charge of Q1 and Q2 at 2 microcoulomb and 4 microcoulomb for each the charge. Then the two charged particles Q1 and Q2 was moved at distance R as shown in table 1 to get the value of electrostatic force using Coulomb law. The value of 1 over R square was also calculated and recorded in table 1. Two graphs F versus R and F versus 1 over R square were plotted. And then for the first graph, we can see that as the distance between Q1 and Q2, R was increased, the electrostatic force was decreased as effect. In opposite, the second graph shows that as the value of 1 over R square was increased, the electrostatic force Fe was also increased. Okay, and here we have the simulation. We have charge 1 is 2 microcoulomb and charge 2 is 4 microcoulomb. And then we have the R. R is the distance between the two spheres, and the Fe is the electrostatic force on Q1 and Q2. Okay, here we have the graph Fe against R versus R. Fe is electrostatic force and R is the distance between Q1 and Q2. And we have here we can see R as R is increased, the Fe was decreased in effect. Next, we have the graph Fe against 1 over R square. As you can see here, it's clearly the linear graph. 1 over R square, as it was increased, the Fe, the electrostatic force, was also increased in effect. And then we have the discussion for part 2. For part 2, we set the Q1 and Q2 at 5 microcoulomb and 3 microcoulomb, and the distance between the two charge was fixed at 6 cm for the rest of the experiment. For Q2 value, the charge was also increased from 3 microcoulomb to 10 microcoulomb as shown in the table 2 to get the electrostatic force. From the linear graph Fe versus the charge Q2 that we plot, we can see that as the Q2 was increased, the Fe was also increased. Here we have the screenshot of the simulation for part 2. From what we discussed, we know that charge 1 is 5 microcoulomb and charge 2 is 3 microcoulomb.
The R is the distance between Q1 and Q2, the two spheres, and the responding variable is electrostatic force. Here we have the graph Fe against Q2. As Q2 we can see here, it is a linear graph. As Q2 was increased, Fe was also increased in effect. Finally, we have conclusion. From this experiment, we are able to observe and graphically determine that the electrostatic force between the two charged spheres Fe is proportionally dependent on the product of the two charges Q1 and Q2, as well as inversely proportional to the squared separation distance between the two charges R squared. Here we have the Coulomb's law. And in the meantime, we had also confirmed that the electric constant K value from Coulomb's law for part 1 it is equal to 8.99 exponent 9, and for part 2 is 9 exponent 9. The result obtained from our graphically representation, the graph, were in agreement in our calculation of the percent error. For K in part 1 it is only missing at 0.11%, and part 2 is 0%, which means there are no error to the K value. Thus, I can overall say that this experiment was a big success.
Here is the members in making our video presentation. The first members is Sutra Seri, the second one is Fatin Nor Maisara, the third one is Rabiatul Adawiah, and the fourth one is Hanan Afifah.
Okay, that's all from us for experiment 1, the Coulomb's law. Thank you for watching. Goodbye.